Hey folks, Quilly18 here, and welcome to another episode of our Unity base building game series, codenamed Project Porcupine. At the end of the last episode, I talked about a few different things I might want to look at today. For example, I talked about, well, I do want to enable sort of proper modding, which is to say, well, modding means modification, but most people think of mods as being quite modular, as being extra modules that you can add in. And I talked about how we might make that work by, hell, I even have a little sort of dummy my mod over here. But there's certain implications that we're going to have to deal with when we get around to proper modding. How do we determine the load order? Do we just load in all the XML and Lua files alphabetically, or do you have configuration files here with priority systems? Do you have a user interface to let the user choose mod load orders, and so on and so forth? And I think that's going to be a lot of questions which aren't that hard to answer, but means putting in a lot of work for something that doesn't actually add any gameplay value at this time. So I'm going to leave things as is. If someone wants to mod the game as is, that's going to be fine. Remember, the streaming assets over here, if we do a build, the streaming assets just get dropped as is in the build folder, so people can still go around and mess around with the XML files, the Lua, and at the end of this episode here, mess around with the, well, not this episode, but this section of episodes, mess around with the images as well. So it's not like, the modding in the format that we will like in the end, but it's still going to be technically possible. And then later on, we will build proper modding, but it doesn't add enough to us right now. So I really want to move forward with the next thing. We do have a few other things on the to-do list, certainly. We've got, we want to make it so that jobs properly get worked from adjacent tiles. We want to have multiple characters. Workers still don't grab objects from the nearest tile when they're building a wall. They just grab it from literally the first one in the array. So there's a lot of little things that we definitely still have on the to-do list for for sort of phase 1 completion, and that's still going to take a little while. But what I want to work on today is I want to move. I've actually already moved some of the folders around as some prep work here. I want to move the images out of the resources folder. So what we've been doing since basically since the start of this project is we have been making as much as possible the various data and UI elements and things like that be less and less and less hard-coded. Our first step was to move them out of sort of normal prefabness to the resources folder. And with the resources folder, so if an image, actually, technically, I moved these are all the Photoshop files. These are all the original Photoshop files. I want to leave them in the project for a little bit longer. These guys, because they're not in the resources file, for us to reference one of these now, the only way we can do it is if we have some sort of game object in our scene, or another prefab, I suppose, but let's say a game object in our scene with a component that's got some sort of field that we can drag the thing into. And that's the only way that anything in here will be included when we build this project out. Because if nothing is pointing to this via an inspector link, then Unity is going to be like, well, nothing's got a reference to it. And it's impossible to load any of this at runtime by simply, referencing its file name in a script. There's no way to do that for a regular file that's just sitting in your project. What you can do, and what we have been doing, is we have those files in the resources folder. And if it's in the resources folder, then it always gets included in your Unity asset bundle when you build it. And Unity has a built-in tool for loading things from the resources folder at runtime. But again, these images that were in the resources folder get bundled up into a single sort of special Unity file that is not easily accessible by the end user. There's really no way to just go in there and mess around with that stuff. It also doesn't load the files in as is. I don't think the PSD gets included in the resources file. It's the sort of converted version into the Unity sort of sprite system, for example. So what we then did with our XML data and Lua data is we moved things out to this streaming assets folder. And streaming assets just gets dumped on the hard drive as is. So if we do a build right now, anyone can go into the streaming assets folder, the data subfolder. They'll just see an XML file called furniture, and they can make changes. I'm going to get rid of the my mod file because that was just an example from last time, and do that. So we're going to do the same thing today with our images. It's also going to enable us to finally clean up some stuff in all of our Sprite controllers, which I've been promising to do for 100 years now. So what I've gone to do as prep work is all our old Photoshop files, I went in there and I exported an actual PNG version of those, because I don't think Unity can load and parse Photoshop files at runtime, and even if it could, you wouldn't want it to because they're huge files that take up a lot of extra hard drive space that you don't want to bundle with your game, and actually, because their size, also take longer to load and all those things. So you want to send your image files in some sort of compressed format most of the time. Sometimes there might be a reason that you'd want to use, I don't know, like a TGA style kind of bitmap or something like that. But generally speaking, you're going to want to use PNG format or JPEG format. JPEG is really optimized for photos. Until you get to really ridiculous levels of JPEG compression, you usually can't tell that a photo has been compressed via JPEG, despite the fact that it's a tenth the previous size, or even a hundredth of the size of the raw images. So JPEG's really good for photography, but it's quite bad for hand-drawn sprites, which of course is what we've got here, right? This sort of like drawing and sketch with lots of sort of flat lines. If we went and save this as JPEG, you'd get a lot of artifacts all over that would be quite ugly. Whereas PNG, just like GIF, or GIF if you prefer, is a sort of lossless format that is optimized for this sort of drawing stuff. Especially the 8-bit version, the 24-bit version of PNG was really designed for more photography type stuff. But whether you save it as 24 or 8-bit, it's going to work great for hand-drawn stuff. So I've done that. So this is just wall.png. So we've got this image here. You'll notice in Unity here, you no longer, if I click on it, like we get no information in the inspector. And why is that? Well, that's because streaming assets are just files that exist as is. Unity literally does not know what to do with it. I think we might still get a preview. No, not even for our XML file over here. Doesn't even give us a preview of the XML file, even though it's just plain text. Unity does not parse them or try to load them, doesn't create any metadata for them in any way whatsoever. But we can tell that these are still working. If I go and grab, say, my inventory folder here, and I'm just dropping it down into my project. So now it's in my project, and if I take the steel plate and I just tell Unity to re-import it, then it'll correctly load it in. It'll recognize it as a PNG, it will create metadata for it and let us make some changes. If I take this inventory folder and I drop it back inside streaming assets, because I'm just dragging it over like this, it still has the metadata and this, but this is not particularly useful. In fact, you may as well just say, hey, just go ahead and re-import it. And by re-import it, what it does is it deletes the metadata, and then it says, well, this is streaming asset stuff. There's nothing for me to import. So then you just got this. So you lose your previews here in Unity, but everything is working perfectly fine, and we are happy. Okay. So let's go ahead and talk about our various Sprite controllers, right? So we've got these Sprite controllers for different purposes. The job of character Sprite controller, furniture Sprite controller, inventory Sprite controller, and job and tile Sprite controllers. The job of all of these is to link some sort of data object. In this case, this is the furniture Sprite controller. So we have a dictionary that goes from an instance of a furniture and points to a game object in Unity, which is the visual sprite. So this is the link between the back-end data and the front-end game object. And we're still going to have different sprite controllers for the different class of objects. There might be a way to do sort of an inheritance model to save like 3 lines of code, but in practice, I think having these as individual Sprite controllers is going to be perfectly fine. And their job is really to track the furniture to game object link, and to respond when a new piece of furniture gets created. We need to create a new game object to represent it. If the furniture changes or goes away, then we have to modify or destroy the Unity game object. And that's what these Sprite controllers are there for. But one of the things they all do, and this code is very literally like copy and paste the same sort of job. The other thing they do is they have a dictionary, which is a string that points to a sprite, so that we can refer to something. And what we had that before is, for example, if we look at our PSD files and say, look at the wall over here, we have a string, for example, say over here, right? This corner over here. This is furniture steel wall southwest. This is a piece of wall that's got a neighbor to the south and to the west, and therefore it looks like a particular piece of wall. We have all these different variants, and they are named different things depending on their neighbors, so we have multiple versions of the wall sprite depending on how their neighbors are supposed to work out. And that's what this link is. It's your fern steel wall underscore SW, which points to a particular variant of the sprite. And well, this part here, this part here and the load sprite part, which is this over here, right? Load sprite. The only real difference between these is load sprite has a particular path in here. And I talked about at a time, like, if there's ever something that should be unified, it's this, right? First of all, you can just imagine a variant of load sprite here that just takes in a string of, like, the path or something like that. So that's one thing. Sting, yes, Sting and the police. That's one thing. And that was like, well, where do you put it and do this? And I was like, I knew, and I'd mentioned this several times, I'm pretty sure we're going to have a centralized sprite manager. And that's exactly what we're going to be working on today. We're going to be working on a new class that exists on the Unity side of things, right? It's not going to be part of our data layer. It's going to be part of our presentation layer. And its job is to load all of our sprites, in particular because Unity has no way to just sort of instantly and freely load all these sprites for us anymore in streaming assets. We have to manually load these PNGs from the file on disk into memory and tell Unity that these are images and here's how you work with them, and then we have to index them. And what I'm going to do is I'm going to create, rather than all of these individual sprite controllers having their own little dictionary of sprites, I'm just going to have one dictionary of sprites. And so right now, the string here is something like fern underscore steelwall underscore SW. Well, the only difference is going to be in our dictionary, the string that's going to be used to index them is instead going to be something like furniture slash wall underscore blah, 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 or inventory slash. The name of the folder is going to be part of the string. And then when our sprite controllers like furniture want to get a sprite, because we have a function, we have functions like that. Get sprite for furniture, get sprite for furniture. Why is it? It's not cycling to the function, which is a little bit annoying, right? These functions here, well, this function may still exist as a bit of a middle glue layer, right? Get sprite for furniture, we pass a piece of furniture in here, and then the furniture has some sort of name, and here we return the sprite based on the sprite name. Well, instead, we're going to be doing something like sprite manager dot get sprite by name, sprite name, like that. So that's it. Sprite Manager is going to be responsible for loading all our sprites from disk and just keeping them in memory in some fashion. So this should actually be relatively straightforward, except that, file system management isn't something we've done a lot of. So this is not really a controller, but it sort of belongs as part of the controllers in a way. It's not really part of, it's sort of the UI layer, but not really. Could be a helper thing. I think I'm just going to put it inside of controllers, and that's going to be okay. So I'm going to create a new C# script, and this is just going to be called Sprite Manager. It's not a controller. Controllers sort of imply they're attached to a game object. Sprite Manager, well, will have to be attached to something to exist, but that's it. I suppose it could just be called Sprite Controller, but again, I don't actually want this. Sprite Manager isn't responsible for actually creating game objects. That is going to be the job of the individual like blank sprite controller objects or scripts. Our job is simply to load all sprites from disk and keep them organized. That's it. Very simple, easy to break things down. I mean, sometimes you want fewer scripts and fewer game objects to keep, your program cleaner. But a lot of times the way to keep things clean is to have somewhat more scripts, but have them all do something very focused, very minimal, very easy to debug and to keep optimized as much as possible. And I think this is going to be a really good sort of segregation of work. Divide and conquer tends to be the solution, and that is entirely what's going to happen here. So our Sprite Manager is definitely going to need, generic, is definitely going to need a dictionary, which is simply string to sprite. So sprites. I guess that's going to be fine. And heck, we can already pre-plan something like we are going to want some sort of public that returns a sprite, get sprite by name. I mean, really, you don't even need by name, because really, it's always going to be my name. By name. String, sprite, name, And all we're going to really do is do something like return sprites by sprite name. Put the semicolon in the right place. And we probably want to do something like if sprites go away. If sprites.contains key sprite name is false. False? God, I can't type anything today. What the hell? It's going to be a good video. Then we're going to do something like debug.log error. No sprite with name plus sprite name. And we could have like some sort of like dummy sprite to return here. I'm going to say like return null. But to do, what if we return a dummy sprite like a purple square? Actually, we don't need to do that because what our other code does is it's going to create a sprite renderer component on an object, and a sprite renderer component needs a sprite. So we're just going to be setting sprite renderer dot sprite, I think, or dot image. I don't remember, one or the other. Dot image to be equal to this, which will be a null, which I believe will render things as an ugly purple square, which is perfect. Again, your goal when making things, your default assumption when it comes to errors is have the error be as loud and as obvious and as obnoxious as possible so it can't be missed. Things that like sort of silently try to do something okay tend to cause more problems in the future. Have things freak out when something goes wrong. Even if that means literally like not catching an error and just blindly trying to use an object, even like so the object might be null sometimes, and then the program will freak out and say, you're trying to do something on a null object. What the hell are you doing? Hey, that's great. Then you know something has gone horrifically wrong. We're definitely not going to need an update. That's a for sure. And I think instead of start, I'm going to use onEnable, because onEnable actually runs before start. And technically, depending on how your program is organized, this could run more than once. Also, here's an idea. I'm thinking, you can tell by the finger tapping. In a sense, this doesn't actually have to be a mono behavior. This could be a static class. A static, like, just normal C# class, which means it would run once at the program boot and just load all of the sprites then. I think we will keep it on mono behavior, at least for now, because it means we could provide some sort of, I don't know, because if it's a static then and it runs instantly at load time, then that means you don't have an opportunity for a loading bar, yada, yada, yada. There's pros and cons. Probably we'll make it as a C# class at some point, actually, as opposed to a mono behavior, but we'll have it be instantiated somewhere else. Maybe it'll just be the world controller will instantiate the sprite manager. I could definitely see that sort of thing happening. But for now, this is going to be fine. It's also going to be really easy for our controllers to find our sprite manager by doing the GameObject.find object of type there, and then they can get a handle on the sprite manager. So that's okay. Or what I could do, and that's probably fine. Pretty lazy way of doing it, but there's no reason it doesn't work. Sprite manager called current, and onEnable, we're just going to set current to be equal to this there. Sort of singleton-ish model, sort of. Oh, public static, like that. Again, not very robust, but it's going to be fine for now. Okay, onEnable, we set current to this, and then we do something like load sprites. I mean, I could put that code in onEnable, but what the heck, right? onEnable may do more things than just this, and then it keeps it very clean, and you know exactly what this function is going to do. It's going to load all the sprites. So we already have a couple of examples about file loading that we can refer to. I think it's in our model. Yeah, model world. If we look that at well, there's load furniture Lua, which isn't actually what I meant. It was create furniture prototypes over here. Right, we have an example of loading data over here. So, file path, there's this helpful little application.streaming assets path in here. to load in. So we're going to want something kind of similar to that, right? So our sprite manager, we're going to want a file path. I suspect that we will need to include some more stuff, but for now we are okay. And the path we're going to get is, yes, from streaming asset path, but the subfolder we're going to use is images. Plural? I'm assuming. Images. Yep, good. Excellent. So we have the file path. Now, here then, we immediately attempt to, we append furniture.xml to this file path, and then we try to read from that. So that's great if you want to read from a file. But we don't want to read from a file. We want to read from kind of all of the files that are in here, including things that are in subfolders. Technically, the images folder does have one file in it immediately. It has cursor circle in there, but then it has a bunch of stuff in subfolders. And what we really want to do is we want to get a list of all of these things. But right away, some of you guys probably should get a sense that there's something a little bit missing. So let me continue on and do a blind example over here of what would be involved in, say, loading cursor circle, which is our little circle that when we drag things out, or that we used to see. We don't really see it as much anymore because we've got the preview system and all that, which is awesome and wonderful and sexy. But yeah, so let's say we've got something like that. Well, how would we load in that sprite? Well, it's actually not too bad. Because, well, we can do the same thing where we sort of append more stuff. So, file path. Let's just hard code this in. That's going to be fine. It's called cursor circle .png. Okay, obviously this is just, sort of testing. And sprite, so our sprite s. There we go. Sprite that has a create from a texture. Right, so it's got this create function, which requires a texture. So it's like, okay, so how do I get the texture? Well, just like here, system.io.file has a read all text, right? So we want to read this in. Well, we don't want to read, our file here isn't text. It's binary information. So we want to read all bytes. Oh, okay, so we can have an array of bytes. So we have image bytes, which we can do this. So lowercase, isn't it? There we go. The difference here is if you read something in this text, oh my god, the history of trying to read text files is one of the hairiest and scariest reads you will ever experience as a programmer. You're talking about line different endings, then you're talking about the introduction of, well, there's different encoding types, and that was before Unicode. Now you've got Unicode and all these things. So reading something in this text actually sort of massages the data in a couple of different ways, whereas reading something as bytes just gives you the raw data as is. And a byte is just, a single byte is just basically a number that can go from 0 to 255. It's effectively the same as a car, but a car is kind of, it's typed, whereas a byte is untyped. Actually, I honestly, I don't know the fineries of these different data types in C#, but something most like that. Okay, so we can read in these bytes, which is great. I'm getting that little error there because of that. And then what do we do from there? Well, sprite.create needs a texture. We saw that. The first argument has to be a texture. So it's like, okay, so we create some sort of texture. So image texture. And we can create a new texture, 2D. That seems fine. We need information. Hold on. Texture 2D dot. Oh my god, I can't remember the function call. Hang on, one sec. Right, now I remember. There was something a little funky about it. Like, I can't just do it directly. There's a load texture, but you don't see it here. So I don't know why it's like this. So you can't just instantiate a texture from a file. And I don't know why that is. So what you have to do is you have to create a new texture. 2D. Oh, hold on. Texture 2D. You create a new texture 2D. And you're like, okay, again, I can't just feed it a file. And no matter what, I need to feed it some sort of width and height. But, I don't know the width and height of the image. It's just a collection of bytes right now. What do you do? Well, this seems really weird. You just create some texture of any size. Here, it's I don't know, it's a 16 by 16 texture. Literally doesn't matter. Hell, that's too big. Let's make it a, I don't know, 2 by 2. texture. You just create some sort of dummy texture. And then once you have an instance of a texture, you can say, load image from some bytes. And this will correctly resize the texture based on the image file. Create some kind of dummy instance of texture 2D. If there's another way to do this, please let me know in the comments, but as far as I can tell, that's the system, which it's mind-boggling, it's weird. I quite like the system for creating sprites. I mean, you can't do it directly, you have to start with the texture. And why is that? Well, the texture is the system that knows how to load things in to memory. And texture is also what you show on the screen. Everything you show on the screen is a texture. The only thing a sprite is sort of a wraparound of texture where you can use just parts of the texture in a very easy way for a 2D system. So what are we talking about? Well, if we go back to our old backup PSD files of our wall here, right, what our sprite editor does is allow us to take our entire texture and specify a portion of it here with a certain set of coordinates and give it a name, give it dimensions. So this rectangle here represents a sprite. It's still part of the same texture. In fact, the texture itself only appears once in memory. The sprites themselves don't create these sort of chopped up versions of the images. They just point to a texture and say, but only use this part over here. So a sprite is just a helper for that, and it ties into the 2D rendering system in a variety of different ways. You know, the sprite renderer wants a sprite, which is just a reference to a texture. So you need a texture at this point, which I'm totally fine with. So we do have, hey, we have an image texture now. Great, we've got that. But you can't just pass an image texture. You need to know, well, something. There's 5 variants of this, but really, the first 2, well, this one here is probably the one we want. But no matter what, we need a rectangle. A rectangle defines the area of the texture that is this sprite here. It also needs to know a pivot point. And you can have this version here, which also specifies pixels per unit, which is actually kind of important because we actually, as a good example, use a few different ones. Our character uses 66 pixels per unit. Our doors and most things actually use, well, I was going to say most things. All right, most things, 3 out of 5, use 32 pixels per unit, but for some reason I decided to draw a higher resolution version of the mining drone and the oxygen generator. For a consistent look, we will probably want to standardize on a particular pixels per unit. So 1 unit in Unity world space is how many pixels on this image. And probably 32 is going to be nice for that sort of pixely sort of look. If you go higher, like 64, then you can draw fancier graphics, but things are going to be rendered relatively small, and I don't know we're actually going to like gain any benefit from doing that, and you lose some of the cool sort of pixel arty kind of thing. Hell, you might want to go down to like 16 pixels per unit for like a really old school look. So we'll probably want to standardize around 32. If you don't specify anything, I suspect when you load just a random image into Unity, it sets this to 100. So I assume if we don't specify anything for the last point, I could load up the reference, but that sounds like work. I assume if we don't specify anything for pixels per unit, it probably defaults to 100. So we don't want that. So what we need is we need some sort of rect. So rect for the sprite coordinates, new rectangle with something. So x, y, width, height. We're going to punch that in a second. It also wants a vector 2, which is our pivot point. Now we know this one. This one's going to be easy. We are going to use the midpoint. Now, so this might be a little confusing. The pivot point is a vector 2 that goes from 0 to 1, is what it wants in terms of numbers here. Where for the x coordinate, 0 would be on the far left, and a 1 would be on the far right. So if you wanted to go bottom left, you would feed in 0, 0. Here is your pivot point. If you wanted top right, you would go 1, 1. And so on. By going 0.5 and 0.5, we are going to have a pivot in the middle of our image, which is exactly what we have been doing over here. Well, eventually. Initially, I got it wrong. But if we look at our pivot, we're using the center point as the pivot. And actually, you can see in the custom pivot down here, it's going to be very small on YouTube. I realize that. But the custom pivot actually says grayed out 0.5, 0.5. And if we were to change this pivot to say bottom left, you could see it goes 0, 0, and so on. But we want center pivot is what we standardized on eventually. Just revert and close that. So that part is easy. We can feed that in. The sprite coordinates actually are in pixels. in pixels. Whereas the pivot is ranges from 0 to 1. Actually, that's often in languages how you specify a range. So 0.5 f equal center. Okay, so this is in pixels. So, I mean, for the image we're loading in here, hard-coded, cursor circle, we actually know the image is just 32 by 32. Or we can say, listen, we want the whole thing. So you're going to start at x and y equal to 0. And the width, you're going to say... There you go. We can do that. That's fine. This works great if we're just loading a single image. And for now, we're going to do this. This is so not what we're going to do later on. Because, again, you're like, well, what about that wall? It's a single image used for the wall, but there's lots of sprites in there. So are we going to chop up that single image of the wall into individual little bits and then have them as separate files? No, we'll still use one file with multiple sprites, but we're obviously going to need some sort of system for determining the coordinates of the various sprites. But let's just start with this. So over here, we are going to be loading in the rectangle, which is the sprite coordinates. There it is. And then the pivot point, which is going to be that. Pivot point is always going to be in the middle. Well, probably? I don't know. And we are going to specify pixels per unit. And actually, I will int pixels per unit equals 32. Like that. There we go. So we can create a sprite that way. And then we've got it. And then what we're going to do is we're going to do something like our sprites. Well, I guess we'll make, tell you what, on enable over here. Well, on load sprites equals new dictionary of sprites. There we go. And over here, we're going to say sprites. I guess I'll have, you know what, let me move something like... Do I want the full path? How do we want to... Yeah, well, let's hard-code it in some more for now, for this example, which we're not even going to run. We're just going to talk about. So this is actually going to be the name of our object, and we are going to be adding that to our dictionary. Cool. Now, we can go and say, let's make a little helper function here. Something like, so load sprites. Maybe we'll have a load sprite singular. And we will do something like, we will have a string sprite name and a string which is the path, like that. And that's going to do... So we'll call it file path. Take this, bring it here. So then what we're going to do is call load sprite, where the sprite name is cursor circle. Come on, circle. And the path is just the file path. Like that, and like that. And so sprite name is what we said over here. There we go. And actually, well, we still do, we still hard code in the coordinates and the pixels per unit. So this is fine, right? Pivot point. Well, we may still be interested in loading things in. Let me back up then. That's going to be okay. All right. So we do hard code in that we're using up the entire texture as our sprite. Pivots in the middle. Pixels per unit is 32. We hard coded all that in. We're going to create the sprite, and then we're going to load it into our dictionary. So that's great. We are manually, we've hard coded in some sort of path here and some sort of name here. But we want to do better than that. What do we want to do? Well, what we really need to do is we really need to load the list of all the files in our folder. So, what am I talking about? Actually, first question is, I think I've gone way over my time budget for this particular video. Yeah, we're pretty much there. Okay, you know what? This is actually a good place to start. So here, this is basically how you load a sprite. And this is totally functional. Next episode, what we're going to do is we're going to iterate through this folder here, images. We're going to go through all the subfolders. We're going to get a list of all the PNGs. That's fine. So then we could load all the sprites into memory, and we'll probably actually start with that. You know what? That's fine. I'm gonna write the code that just loops through all here and finds all the PNG files. But the other thing we're gonna need to do is we're gonna have to create some sort of, most likely an XML file that describes all of these. It's like, great. So we go through here and we find that in furniture we have some sort of file called wall. And what are we going to do with it? Well, there's going to be some sort of attached XML file that says, yeah, okay, so you've got this image called wall.png, but it's going to be split up like this. There's going to be a sprite called fern steel wall _, which is going to be at this coordinate, x0, y224, and it's got a width of 32 and a height of 32, and that is one sprite. It's going to be called this. So everything that you do here in the sprite editor, we are going to be doing via probably an XML file and these function calls. We're most of the way there. It's not going to be hard at all. We just have to make sure we do it right. And then in the end, we will have a beautiful little dictionary of all our sprites indexed in a certain way. And then all we're going to do is go into our various Sprite controllers and remove their load sprite area and remove their dictionary, right? Remove this dictionary and remove their load sprite function. And instead, when they go looking for a sprite, they're just going to talk to Sprite Manager. It's going to be awesome. Thanks for watching. See you next time. Thank you everyone who pledged on Patreon to support these videos back in May and are therefore keeping this series going from June through to early July. And a special thank to these Mike Check level supporters. We got Speedy Savant, Valiant Cake Fiend, Aaron Toibson, Marius Field Vold, Jan Torrevel, Julien Auger Lafont, Steven Stager, Michael McClintock, Kale the Quick, Drazion, Adjective, Jason Yanity, Wes Oldenboving, Craig Mortel, Neil Blakely, Milner, and absolutely everyone who watched, shared, favorited, and subscribed these videos. Thank you very much for keeping this series going, and I'll see you next time.